For this video, we'll be discussing the continuation of working with Java class. So here, I'll be particularly discussing about typecasting. So typecasting is converting data type of one data to another data type. So we have several data types. We have, of course, we have the primitive data types and the objects themselves. So the primitive data types, examples of these are integer, float, double, etc. So what we'll be discussing here is casting data types or data with primitive types and also casting objects. Casting primitive types. Casting between primitive types enable you to convert the value of one data from one type to another primitive type. Commonly occurs between numeric types. There is one primitive data type that we cannot do casting though, and that is the Boolean data type. So we cannot cast Boolean data type. So there are two types of casting here, with the implicit casting, or that's implied. So we did not place any code, but Java will automatically do the casting or do the conversion. Then we also have the explicit casting. So wherein we have to specify to what data type we're going to convert. So implicit casting. To illustrate implicit casting, let us give an example. Suppose we want to store an integer data to a variable of data type double. So if you notice here, num_int here is an integer and num_double is a double value. And what we're going to do is to store the integer in this numeric value. So these are two different data types, but what will Java do is to automatically convert this one into double and store it to num_double. Okay, so again, in this example, since the destination variable double holds a larger value, so this should be a larger value than what we place inside. The data is implicitly casted to data type double. Implicit casting, another example. So in num_int1, num_int2, and then double, num_double. And what we did is we divide this one. So the division now is converted into a double value. So these are implied. So we did not explicitly casted the objects or the data types rather. Excuse. Explicit casting. So when we convert a data that has a large type to a smaller type, then we must use an explicit cast. So from larger type to smaller type. So be sure that you know how many bytes are needed to store value. So explicit cast takes the following form. So we just enclose in parentheses the data type, then followed by the value. So where data type is the name of the data type you're converting to. So it can be an integer, etc. So float, double, and value is an expression that results in the value of the source type. So explicit casting examples. We want to typecast an integer to a char value or vice versa. A character, so if you notice here, there's no need to cast. A character can be used as an integer because each character has a corresponding numeric code. So the letter A is actually number 65. That's the ASCII code of letter A. So numeric code that represents each position in the character set. So A is 65. So since valchar here is A and we store A inside valin, so what is contained in valin is not letter A but the number 65, because that's the ASCII code of the character letter A. So here's another example of casting. So we have here double 10.12, and double is of course more bytes than integer. So what we did here is to cast val double using int to this data type. So 10.12, so that will be equal to 10 now. So here, double 10.2, integer 2. So we divide x by y. So we have to convert that into an integer. So we have int, then the result is in the form of an integer. So that is how we cast. So this one is casting. We specify the data type. Casting objects. Instances of classes also can be cast into instances of other classes with one restriction. The source and the destination classes must be related by inheritance. One class must be a subclass of the other. So we'll cover more about inheritance excuse me, in the later chapters. Excuse me. Excuse me. Casting objects is analogous to converting a primitive value to a larger type. Some objects might not need to be cast explicitly. So to cast, we have the class name and then the object, where the class name is the name of the destination class. So that's a destination class. And object is a reference to a source object. So the following example casts an instance of the class vice president to the instance of the class employee. Vice president is a subclass of employee. So they belong, this one is a subclass. So it inherited from employee, its properties and methods, etc. with more information. So which here defines that the vice president has executive washroom privileges. So that's some of the added maybe method to this one. So here we created an employee, an instance of employee. We also created an instance of VIP or vice president. So they belong to this class, M from the employee class and VIP from the vice president class. So here we can just place M is equal to VIP because this is a subclass, we can place it here. But here, since this is the main class, then we have to explicitly cast. So VIP equals vice president M. Okay, so M here is the main class. This is just a subclass of this class. So from the lower class or subclass to the main class, then no need for casting. But from subclass or converting to a subclass from the main class, then you need to explicitly cast. Converting primitive data types or primitive types to objects and vice versa. One thing you can't do under any circumstance is cast from an object to a primitive data type or vice versa. As an alternative, the java.lang package includes classes that corresponds to its primitive data type. So these are float, boolean, byte, and so on. So notice they are in uppercase. So these are classes. So we call them wrapper classes. So converting primitive types to objects and vice versa. So wrapper classes. Most of these classes have the same names as the data types, except that the class names begin with capital letter. So short instead of short, so uppercase S, double instead of double, and the like. Two classes have names that differ from the corresponding data type. Character is used for char. So instead of char, we use character, and integer for int. Using the classes that correspond to each primitive type, you can create an object that holds excuse me, the same value. So converting primitive types to objects and vice versa. So for example, the following statement creates an instance of the integer class with the integer value 7801. So what's primitive is the object. So this is an object. Data count here is an integer object. So integer data count equals new integer and then 7801. And here we use this object, that int value, to convert this value into a primitive type integer. So the following statement converts integer object, so that's data count, that's an integer object, to its primitive data type, which is int, and the result is an int 7801. A common translation you need in programs, so we have actually done this already, is converting a string to a numeric type such as int. So object primitive. So here, for example, string Pennsylvania equals 65,000. So how do we convert string to integer? So we use integer.parseInt, and then we have here the value of the string. So this will be converted into an integer and then placed inside this variable. Now, how do we compare objects? In our previous discussions, we learned about operators for comparing values: equal, not equal, less than, and so on. Most of these operators work only on primitive types but not on objects. The exceptions to this rule are the operators for equality, so double equal and not equal. When applied to objects, these operators don't do what you might first expect. Instead of checking whether one object has the same value as the other, they determine whether the both sides of the operator refer to the same object. So are they the same object? Not the same value, the same object. Take note of that. It says here the same object. So example here, we have two strings here, str1 and str2. So str1 contains free the bound periodicals. str2, the value of str1 is stored in str2. So they both have the same value, but these are two different objects. So if you print str1, if you print str2, they will be printing the same value. Are they the same object? So we use double equal. And then here, what we did here is str2 is equal to new string str1. We created an instance of str1 to str2. Then we print their values. Is str1 the same as str2? The same value. So equals. This is how we test if they have the same value, not the same object. So here, if we use this one for a string, so same object, it becomes true. But if you declare it as something like this, as a string object, then you compare it, then although they have the same value, the same object is false, but their value is true. So equals here will compare the value. This will be just comparing if these are two the same objects. So str1 is not the same as str2 because str2 was just created here. Now comparing objects, given the code str1 equals hello, str2. So these two references, str1 and str2, will point to the same object. String literals are optimized in Java. If you create a string using a literal, then you use another literal with the same characters. Java knows enough to give you the first string object back. So these are as if they are both the same object. Both strings are the same objects. You have to go out of your way to create two separate objects. Now, how do we determine the class of an object? You want to find out what an object class is. So here's the way to do it. Suppose we have the following object. So some class name key is equal to new some class name. Now we'll discuss two ways to know the type of the object. Point to the reference key. So this is the object name. So what is the class of this object? So first we have the getClass method. The getClass method returns a class object. So it returns a class object where class is itself a class that has a method name called getName. So in turn, getName returns the string representation of the name of the class. So for example, here is the object that getClass. We now have the class. Then that getName, we have now the string representation of the name. So the name of the class will be placed inside this variable. Okay, again, this is the object. So you get the class of the object. Once you know the class of the object, you can now use the method getName to get the string representation of the name of this class. So what class is key? And then that will be stored inside the variable name. Then we have the instance of operator. The instance of has two operands, a reference to an object on the left and a class name on the right. The expression returns true or false based on whether the object is an instance of the name class or any of that class subclasses. So example, Boolean X equals Texas. So instance of a string, true. object point equals new point, and then boolean, I think it should be string. Boolean ex2 is point instance of string. Is point an instance of a string, so it says here false because point is not actually a string. So summary. So we have discussed the first three in our previous video. So classes and objects. We have learned what are instance variables and class variables. So class instantiation. So we use a new operator. Methods, instance method, passing variables by value, static methods, and we'll be having more examples of this as we go on. Scope of variables, we have discussed this. And then what we have discussed for this video is casting object and primitive types, converting primitive types to objects, and vice versa. How do we compare objects and how do we determine the class of an object? So thank you very much for viewing this video lecture.